All right, this is lesson 6.4 in pre-algebra, probability. Okay. I don't know, I think you guys probably did a little bit of probability last year with Mr. M. Here's the deal. Here's the deal about probability. Okay, so I really need your attention here. Just need you to understand the concept. If you understand this concept, then probability is kind of easy. What is the, every possibility, everything that, every odds, every probability question, everything when I say, what's the likelihood of something happening? Or what is the probability of something happening? Or what's the odds of something happening? They all fall between two numbers. Everything falls between two numbers. That is 0 and 1. That's the truth. When you're dealing with probability, every possible solution will land somewhere between 0 and 1. Here's the deal. What if I took a regular die? Okay, what if I took a regular dice and I said, what's the probability of me rolling a 0 or an 8? Here's my dice. I'm going to roll it once. And what's the probability of me rolling a 0?
0.
You'd say that is impossible, right? You say it's not possible. There's only 6 numbers on the die. So it's impossible to roll an 8 with one die since there's no 8 on there. So here's the deal. Another name for 0 would be impossible. Impossible. And what if I said this? What if I said, okay, what is the probability of me rolling a whole number? What's the probability of me rolling a whole number? It would be 6 out of 6, or you'd say it's guaranteed, right? The odds of me rolling a whole number are guaranteed. Do you agree?
Unless it's a negative dice.
No, but on a regular dice, what's the probability of me rolling a whole number is guaranteed, right? So here's the deal. Every possible odds will land somewhere between impossible and guaranteed to happen. Is there anything that could possibly happen that wouldn't land somewhere in between there? Right? No matter what. If I said, what's the odds of me winning the lottery tomorrow? Okay, well, it's going to be very, very low. In fact, it's going to be very, very close to impossible. But there is a possibility. I mean, it would land like right there, right next to it, right? What if I said, what's the odds that I wake up in the morning? That I don't die in the night? It would be almost guaranteed, right? I mean, I could die in the middle of the night, but it would be almost guaranteed. Agreed? Okay. All of a sudden, though, if I said, okay, what's the probability that the next car that drives by Buena Vista is white? That's probably going to land somewhere in, nearing impossible, but it's not impossible. You know what I'm saying? But it would be, are the odds likely that the next car would be white? Is that probably going to happen? Here's the deal. Here's the line of right in the middle, the 50% line. The 1/2 line. The likelihood line. In other words, the likelihood line, meaning if I said this, what is the probability of the next time the girls played basketball against Tabernacle that we would win? Here's the deal. If we played basketball, say Tabernacle's really good at basketball. Here's the deal. It probably would land on this side of the likelihood line, which would mean you would say that it's unlikely. You'd say it's unlikely. Does that make sense? If I was to say in softball, what's the probability that we beat Contra Costa Christian, right? Then you'd say it would be likely. Does that make sense? It would land somewhere. The likelihood line is just, like if I said, what's the probability that Sheena is going to pass the next Bible verse test? You don't know. Sheena might not study. But what would you say? You'd say that it was likely that she would pass the Bible test. Does that make sense? Okay. This is the likely, and this is the unlikely. Okay. Anyway, that 50% line is important. But anyway, the closer you go, the less likely it is, the closer to 0 it gets, or the closer to impossible it gets. The more likely it is, the closer to 1 that it gets. You can also look at this as percents. Like I put the 0% there, right? If I said something is a 10% chance of, the odds of us beating Tabernacle, we'll say, is a 5% chance. That means that it's going to land somewhere over here, right? Here's 5%. In basketball, whatever. That's what that means. That we're getting, it's less and less likely. Okay? Anyway, understanding that they all land between 0 and 1. All probability lands between 0 and 1. There's nothing that can be higher than 1 and nothing can be less than 0 because you can't get any more than guaranteed and you can't get any less than impossible. Make sense? Okay. So here's the deal. Here's how probability works. If I were to, we'll just take a regular old die again. Okay, there's our die. And I was to ask you, what is the probability, and this is how I write probability with a P in parentheses, probability of rolling a 4. Now, here's the deal. I know a lot of you know the answer. I don't care. That's not the point. Here's the deal. This is how we do this. Okay, and this is how you do all probability. It's just that a lot of times it gets more complicated than this, but this is the basics. It is always a fraction. Okay, you write it as a fraction. And this is the total number of possible outcomes. Okay? And what's on top of that is the number of favorable outcomes. Now, what in the world does that mean? Okay, so here's the deal. This is actually a ratio. Okay, it's a fraction. The total number of possible outcomes. When I roll a die, how many possible outcomes are there? When I roll a die, how many possible outcomes are there? There's 6. Agreed? There's 6. Okay. How many favorable outcomes? In other words, how many things would make you go, yes, I did what I was trying to do? How many ways could I roll a 4? There's only one number 4 on the die. Agreed? So the probability of me rolling a 4 is 1 out of 6. Does that make sense? What if I was to take a spinner, and we have 8 slots here, and here's red, blue, red, blue, red, green, red, green. Okay, and so here's the deal. If I was to ask you what is the probability of spinning green, here's what you do. Here's what you do. Same thing. You take this and this is the number of favorable outcomes over the number of possible outcomes. I always find the number of possible outcomes first. It's just what I do. How many different possibilities are there? How many possible, when I spin that thing, how many possibilities are there? There are 8. Do you see them? There are 8 possible things to do. It's not 3. Yes, you could only get red, blue, or green, but that's not how it works. How many different of these little pieces could it land on? 8, right? There are 8 possible landing places with the spinner. How many number of favorable outcomes? How many outcomes are there that I would go, yes, I did it? How many of these things are green? 2. Now, here's the deal. 2 out of 8 is not incorrect, but it can be reduced. You would say it's 1 out of 4. Does that make sense? That's the probability of spinning green. Okay, what's the probability of me spinning red? Total number of possible outcomes? 8. Right? Total number of possible. Don't start skipping. You start skipping, that's cool. When things get more complicated, you will miss them. What is the total number of possible outcomes?
4. 8.
No. 8. Total number of possible outcomes is 8. Listen to my words. It's important. 8. How many favorable outcomes? How many ways could I go, yay? There are how many, what did I say, reds? 1, 2, 3, 4, 4. That reduces to 1. You don't say half. You would say it's 1 out of 2. Does that make sense? When you're talking about probability, you say it's 1 out of 2. Okay. Instead of having number of favorable outcomes over the total number of possible outcomes, I change this to something very simple, and it's yays over ways. In other words, how many total ways could this thing land? How many total ways could this thing go? How many total ways, right? Just whatever we're talking about, it's the total number of ways it could happen. And then the number of yays is how many, yay, it worked, or yay, I did it. Does that make sense? You can do this with any number of things. If I have a bag and it has a star, a circle, a circle, a circle, a square, and a triangle. If I did this, and I was to say, okay, what is the probability of me pulling out a circle? Here's the deal. This is very important. You go yays over ways, right? Yays over ways. I would write that down, right? I would write down yays over ways on your paper somewhere so you can remember, because that's the probability. That's how it always works. Yays over ways. How many ways are there for me to pull out something? How many total ways? There are 7 ways I could pull out something. Agreed? I could reach my hand in the bag and there's 7 different things I could pull out. How many yays are there? How many ways could I go, yay, I did what I was supposed to do? There are 3. The probability of me pulling out a circle is 3 out of 7. Make sense? Okay. Let's see if they have us do anything that's complicated. Okay, here, let's do this. Let's just say that I have some flashcards, okay, and it is cool. Okay, the letter C-O-O-L, okay? C-O-O-L, makes sense? And I was to say, okay, I put these cards in a deck, and and I'm going to shuffle them, and I'm going to, okay, what is the probability that I pick the C? That I pick the C? What do you guys? Can you figure that out really quick? What's the probability? 1 out of 4. Agreed. So then this is what they would say. The odds in favor of me pulling out a C is 1 out of 4. Agreed. What is the odds of me? And they would say, what is the odds against me pulling out a C?
3 out of 4.
It's if it's 1 out of 4 that I do it, then the rest of the possibilities are the odds against it. Does that make sense? So you would figure out what it is the exact opposite of that, or what is it that makes it 1. So then you'd say the odds against would be 3 out of 4. Does that make sense? If they ever ask you to find what is the odds against something, you could figure out what is the odds of it happening, and then just figure out what would make that thing a total of 1, right? Because if you take the odds for something and the odds against it, that should equal 1. All right. Okay. What is the probability? Here's my dice again. What is the probability of not rolling? Oh, no. Okay. Hold on. Probability of rolling a 3, 4, 5, or 6. What is the probability? Now, here's the deal. This is where you really need to do this. Yays over ways. How many ways are there rolling a dice?
6.
There are 6. How many yays are there? What are the things I'm trying to do?
4.
What are the things I'm trying to do?
Roll 3, 4, 5.
Roll it 3, 4, 5, or 6. So how many yays are there?
4.
There are 4. 3, 4, 5, or 6. That would all work. 4 out of 6, 2 out of 3. That's the probability of me rolling a 3, 4, 5, or 6. What's the probability that I don't roll a 3, 4, 5, or 6?
2 out of 6.
2 out of 6 or 1 out of 3. Does that make sense? Does that make sense? Seriously?
Yes.
The odds of me not rolling that would be whatever would make this add up to 1. So if the odds of me rolling that is 4 out of 6, then the part that doesn't is 2 out of 6. Right? Okay, so what is here's my dice again. What is the probability of me not rolling a 4? What's the probability of me not rolling a 4, Jade? 5 out of 6. You wouldn't say 5 over 6, say 5 out of 6. We're talking about probability. It's out of, right? 5 out of 6. Because what's the probability of me rolling a 4? 1 out of 6. So then the odds of me not rolling a 4 are 5 out of 6. Does that make sense? If I tell you that the odds of a white car coming down the road is 1 out of 10, then what's the probability that any other color car but white was to come down the road? 9 out of 10. You guys get that concept, right? It's not difficult. Okay, I think we're in good shape then. Let me get you started on your homework. Today is December 1st. Page 308, 1 through 33 even.